Hello everyone. So today we're having a look at probably the main thing when it comes to models and simulation. And in fact, one of the main things that comes to Python. It's what's made Python so powerful, and that's the idea of class. Um, Now I've already talked to you about agent-based simulations and agent-based programming. So I'm going to show you the example. Now this is like the most rudimentary example that everyone, and I mean everyone, should be able to do at least this. But if you can understand and maybe recognize the structures that are involved here, then when you see a more complicated object-oriented program, you will be able to recognize what's going on just from this very simple example. So listen, this I'm literally going to create something, okay? So some people might this is like the seed of an AI, okay? And all this AI is going to do, this something, this agent, this class type, all it's going to do is move. Okay, now there's going to be no fancy, 3D rendering of this. This is all going to be 2D happening with numbers. But you should be able to see from this how you could actually make this type of code do anything you want it to do. So, I'm going to start very simply. We're going to define the constants which kind of define this class. Okay, so it's obviously going to move on a grid. So we start with very simple. Okay, uh, grid of 10. Okay, it's a 10 by 10 grid. Okay, we obviously need some creatures, so I'm going to put 5 of them, and then each of these creatures can move a number of steps. So we give 10 steps. So each of these creatures is going to move 10 times. There's 5 creatures, and they can only move inside a grid that's 10 by 10. Okay. So here we go. Let's create our first class. Now, when you're creating an agent in a class, you need to do two things. The first thing, every agent is going to have some innate quality, something that defines it. Okay? And unusual is how you initialize. So we're going to give him a name, call it self, we can call it anything you want, and he only has two possibilities, two other defining characteristics of it. In this case, it's going to be X and Y. And of course, I'm going to feed stuff into X and Y. And in this case, all I'm doing is feeding in the coordinates into X and Y. So that'll be the way he move. Okay? But that's literally it. That's how kind of, that's how he works. So anywhere further down in the code, if I want to talk about this agent, I can just use self now, rather than have to keep using the word agent. Okay? Now, once you've done that, then you can start creating other functions to make him do stuff. Because now you've got your built-in function about himself or herself or itself, and now you're going to have other things. So we're just going to make him move. And what are we going to make move? Well, what's his name? His name itself. Right, move is not spelled with an R. No. We're just going to make him move one of four ways: up, down, left, or right. Okay. Now, I'm not going to make a move. We're going to randomly make a move, because this is where you need to get that kind of, if it's object orientated uh, kind of movement, then the object needs to be random, or as random as you can make it. So let's just import the random function. We can actually use it down here. So you've done this before with different things. And let's throw a list up in here. up, down, left, right. So that's just, you could have that list defined somewhere else, but define it inside in the choice. You know, it's just going to move, and it's simple Boolean then. If direction is equal to up, well, then we have to move up and down, or you'll be calling the self y, won't you? Self dot y. Um, let's say it's going to change it by 1, and we're just going to repeat this. Else if direction equals to down, self y. No, I'll get an error there if I don't do that. Self y plus equals 1. I'm just going to copy this because it's the same crap again. Left, right, and these need to be x's. Now let's try and figure this out. If he's going left, he'd be the minus, and if he's going right, he'd be the plus. Right, there he is. There's our function to make our agent move. Okay, and we've got our conditionals. Right, so again, now we've done everything. That's inbuilt. There is our little creature. A very simple creature. You can only move up, down, left, or right randomly. Now let's try and actually tell him to move. You know, he knows how to do it, but he needs to be told to do it. Okay, so create an empty list because we want to print this and try and range. We only want him to. There's only 5 of them, so we only want 5 of them to actually. Just you can put an input on that if you want num underscore because you can change this. So for the 5 times basically. And what do I call the grid? I need to keep them inside the grid. So n is the grid, so between 0 and 9. Pick a number, x will go between 0 and 9. And obviously y, copy that again. This is where y, so think about it there. The x and y values, which will be pumped in here, can only come inside in a 10 by 10 grid. So I can't use 10 or 10. I want to keep them inside that grid. So I'm using 10 minus 1. The most it'll go to is between 0 and 9, 0 and 9. Okay, so it'll stay inside the grid. In other words, I'm telling the animal you can't leave the 10 by 10 grid. So that's his kind of exclusion zone, for want of a better word. So obviously the agent I've defined here, this on 921, the empty one, because we want to collect all these coordinates. And we're going to call now our class and the X and Y from our class. So look, that agent is just a blank list that I'm going to be able to print, and it's going to contain the coordinates, which is the coordinates that are generated from this. Okay, so there you have, and obviously we need to append them on. So we need to append them on. So let's try and think. Agents dot append agent. So if I'm right, all line 25 will get stored in line 21. That should give us those numbers. So let's run this simulation. We're doing steps, aren't we? Won't use I again. What's the range? Well, the range is the number of steps. What do we call that at the top? Num steps. Basically, for something for I in range 10 is what you're basically doing there. Again, I'd like to see what's happening at every step. I don't want to just go to the last step because then it's not showing me movement. So it'll go step 1, and then it'll show me what happened in step 1. Then it'll increment that. Step 2, you know what I mean? It'll keep up to step 10. Now let's get our agents going. These are the actual coordinates. How do I get the coordinates? Whatever agent.x is. That'll print out each coordinate at each iteration of this. And then we need to get, and once that's printed off, we then need this. We need this to actually activate the move. Let's see, does that work? Oh, right, error expected. So this is on line 7. Line 7. Ah, the function, and I didn't put the semicolons. Or at least that's not too hard to fix. Okay, expected an indented block on line 8. Again, look, we've got a function, and I didn't indent the block. Again, that's the great thing about debugging. Okay, let's run this again. Okay, line 25. And 25. Let's have a look. Line 25. Agent takes no argument. Agent takes no argument. Let's see. Up, run. Yeah, did. That's what it was. Brilliant. Okay, so at position 1, the first animal or first creature was at 8499. At position 2, 83. So they are moving. Yeah, they're moving around. Now, I'm noticing some of them are going outside. They shouldn't be going outside. So again, that's something I need to fix in the code. It's the same one. It's the second fella. I'll have to check that I'm not doing something silly here with it. Okay. Self. A minus equals 1 and a plus equals 1. And a minus equals 1 and a plus equals 1. So it could be just something silly like that I'm doing wrong there. Trying to see. What could I be doing there? Anyway, it's a small error. It's not a big problem. I can chase that around and fix it. But that's it. Look, these agents moved independently on their own. You can see that there. So that's your very first agent-based modeling. Okay. So these creatures are randomly moving around. The extension of this are like powerful. Like for example, you could simulate what would happen if white blood cells encounter. So you know if a white blood cell is at A2 and a bacteria is also at A2, you could put in another rule here that if an agent and a bad guy are both at the same one, then there's a 50% chance that the good guy, will kill the bad guy, and then play that out over a couple of thousand iterations and see what happens to the disease. Will it progress? There's loads. I mean, populations here are the connotations and the permutations here are just endless. Okay, right. Thanks very much.